So let us start. So we'll discuss free body diagrams today. So first of all, we'll start with a well-known problem which is known as the Atwood's machine. So do you know what is Atwood's machine? So let's suppose we have a pulley. Okay, this is a pulley. So it can rotate freely, and there is a string passing over this pulley. Okay, and there are two masses, M1 and M2. M1 and M2. Okay, so now these two masses, they are initially they are held, okay, and after some time, let's suppose they are left. Okay, so this system, starting from this configuration, it is left. Okay, so what will happen? So this system will accelerate. So let's suppose m2 is greater than m1. So what will happen? The system will accelerate in this direction. Okay, this mass will go down, this mass will go up. So we want to find out the acceleration of this system. Okay, so for that, what we will do is we'll draw the free body diagram of masses m1 and m2. So what is free body diagram? So we have used free body diagrams earlier, but we just didn't call them free body diagrams. I'm sorry. So we have used free body diagrams earlier in case of dynamics of circular motion, etc. But we just didn't call those free body diagrams. Okay. So what are free body diagrams? You consider a body, you draw all the forces acting on that body. That's it. Okay. So what are forces acting on M1? There are two forces. One is the gravitational force, which is acting downwards, M1 times G, and other is tension in the string. Okay. So for this string, okay, this is one string only. So tension on this side and on the other side of the string will be same. Okay. So tension is suppose T. For second mass, we can draw m2 times g is the gravitational force. Tension in the string acts upwards. Okay. All right. So now let's suppose this system accelerates like this. Let's suppose m2 is greater than m1. So we want to find out this acceleration. So m2 is greater. So system accelerates like this. So now how much would be the force, net force on m2? It will be m2 multiplied by acceleration, right? It is m2 multiplied by acceleration, and net force on m1 will be in upwards direction. How much will be that? It is m1 multiplied by acceleration. So now we can solve this. So for mass m1, what can we write? So for mass m1, we can write net force is in upwards direction. So m1 times a is equal to total upward force T minus total downward force m1 times g. Let's call this one equation number 1. For m2, what can we say? That net force is downwards. So m2 times a for mass m2. For m2, we can say m2 times a is equal to the total downward force, which is m2 times g, minus total upward force, which is t. So it is m2 times g minus t. So this is our equation 2. What we'll do is we'll add equations 1 and 2. So let's add 1 and 2. So this equation and that equation, if we add them, so I add in this equation m1 times a equals to, on other side, t minus, it is t minus m1 times g. I am adding these two. What happens? T and t gets cancelled out. Okay, and then on left hand side we have m1 plus m2 multiplied by a, and on right hand side I can take g common. So if I take g common, it is m2 minus m1. And if I move this m1 plus m2 on right hand side, what do I get? I get the acceleration a equals to m2 minus m1 divided by m1 plus m2, or m2 plus m1 multiplied by g. So this is the standard formula that we'll remember. Okay, so if we have Atwood's machine, what is Atwood's machine? There are two masses connected to a string which is passing over a pulley. Then acceleration of this system is what? It is greater mass minus smaller mass divided by sum of two masses multiplied by g. Is this thing clear? Clear. Good. So now let us solve some problems based upon this, which were asked in the NEET exam. So we have two masses as shown in the figure. Okay, so this is Atwood's machine. They are suspended from massless pulley. Okay, these are suspended from massless pulley. The acceleration of the system when masses are left free is very simple. So let's call this one m1, this is m2. Sorry, what's our formula? So formula is acceleration is m2 minus m1 divided by m2 plus m1 multiplied by g. So what is m2? m2 is 10. Okay, weight is 10 times g, that means mass is 10, minus this is 5 divided by 10 plus 5 multiplied by g. So how much is this? 10 minus 5 upon 10 plus 5. So 5 divided by 15, or 1 by 3 you can say. Okay, so answer is g by 3. Simple. Okay, straightforward question. Right. Let's see next one. This is recent one, NEET 2020. Okay, two bodies of masses 4 kg, 6 kg are tied to the ends of massless string. The string passes over a pulley which is frictionless. Okay, similar question. The acceleration of the system. So again, this is m1, this is m2. Okay, so acceleration is g by 5. Good. So let's solve. 6 minus 4 divided by 6 plus 4. Okay, multiplied by g. Right. So this is 2 divided by 10. Right. 1 by 5. Okay. So g by 5 is the answer. So these are simple questions. Right. So we have to memorize this formula. Okay. m2 minus m1 divided by m2 plus m1 multiplied by g. Then next thing that we are going to discuss is a lift. Okay. So let's suppose that this is a lift. Okay. And there is this man inside the lift. So there is mass of lift is suppose ml, mass of the man is, let's call it small m only, and capital M is the total mass. So how much is that? Mass of the lift plus mass of the man. Okay, and there is this string connected to the lift. Okay, this is rope of the lift. Okay, so there will be some tension inside this rope. So tension is suppose T. Right. So how much is the total weight acting downwards? The total weight acting downwards, it is equal to capital M times G. Right. So now this lift can accelerate upwards or it can accelerate downwards. Okay, it can go steadily. That's one case. In that case, T will be equal to M times G. It can accelerate upwards or it can accelerate downwards. Okay. So now let's suppose it accelerates upwards and A is the acceleration. Okay, So what can I say about the net force? So net force on lift when it accelerates upwards, when A is upwards. So net force is M times A. Okay, mass of the lift plus mass of the man is capital M, and it is equal to what? Net upward force, which is tension. Okay, tension minus net downward force, which is M times G. So from this we can find out tension. So what will be tension? Take mg on the other side. So you get tension equals to m multiplied by a plus g or g plus a. Okay, I will write g plus a. Okay, so this is the tension. When lift is accelerating upwards, acceleration is a, then okay, tension will be what? M multiplied by g plus a. So can you guess when lift accelerates downwards, what will be the tension? This is m multiplied by g plus a. That one will be m multiplied by g minus a. Okay, let's find it out. So we have this lift and this man inside the lift. Total mass is m, okay, which is mass of lift plus mass of the man. And now the total weight, of course, acts downwards. Tension in the rope of the lift acts upwards, and acceleration is suppose downwards. Okay, so the net force when the lift accelerates downwards, okay, that is m multiplied by a, and now it is mg minus t. Okay, so net downward force minus the upward force. Okay, that is the total force which is acting downwards. Okay, so now take tension on left hand side and ma on right hand side. So you get tension equals to mg minus ma, that is m multiplied by g minus a. So this is tension in the string, tension in the rope of lift when the lift is accelerating downwards. Is this clear? When the lift accelerates upwards, tension is m multiplied by g plus a. When it accelerates downwards, the tension is m multiplied by g minus a. Okay, so now let us solve problems based upon this thing. So there have been quite a lot of problems on lift. Okay, so a person of mass 60 kg is inside the lift of mass 940 kg and presses the button on the control panel. The lift starts moving upwards with acceleration 1 meter per second squared. If g is equal to 10 meters per second squared, the tension in the supporting cable is very simple, right? So lift is accelerating upwards with acceleration of 1 meter per second squared. So what is the tension in the supporting cable? So T is equal to, we just found, it is mass of man plus mass of lift, which is total M multiplied by G plus A. It's accelerating upwards. Okay. So how much is the total mass? 60 plus 940. Yes. 1000. It is 1000 kgs. And G is, let's suppose it is 10. 10 plus, okay, A is 1. So 11. 11 multiplied by 1000 is 11,000 newtons. Okay, so very simple, right? Okay, yes, no? Next question. The mass of a lift is 2000 kg. When the tension in the supporting cable is 28,000 Newton. Okay, it's given now. The tension is 28,000 Newton. then its acceleration is. Okay, so now mass of lift is given, there is no man inside lift. Okay, so it's the total mass only. So how much would be weight? Weight is equal to this 2000 multiplied by 10, 9.8, let's say. Okay, it's 20,000, right? And how much is the tension? Tension is 28,000 Newton. So is it accelerating upwards or downwards? It's accelerating upwards. Tension is greater than weight. So it is accelerating upwards, right? Yes, no? Okay. Or see, the trick is you can do this thing. Let's suppose it accelerates upwards. Okay. So let's suppose it accelerates upwards. Okay. So you have T equals to what? M multiplied by G plus A. Okay. And T is given. It is how much? 28,000. Okay. M is 2000. G is 10 plus A is something. We have to find out. So 28,000 divided by 2000 will give us what? 14, right? Yes, no? 1, 4. It's equal to 10 plus A. That means A is equal to what? A is equal to 4 meters per second square. So if this is positive, then our assumption is correct. If it comes out to be negative, then our assumption is wrong. Okay, it will be in opposite direction. That means it will be accelerating downwards. Simple. Okay, so since this is positive, our assumption is correct. Okay, so our assumption is correct that it is accelerating upwards. So 4 meters per second squared upwards is the answer. Very simple. Same formula repeated many times. Right? Is there a question in this? A man weighs 80 kg. He stands on weighing scale in a lift. Okay, in moving is moving, which is moving upwards. Sorry. A man weighs 80 kg. He stands on weighing scale in lift, which is moving upwards with uniform acceleration 5 meters per second squared. What would be reading on this scale? Okay, so this is slightly different, but it is based on the same principle. So there is a lift and there is a weighing scale on the lift. Okay, so this is the man inside the lift. So there would be some normal reaction. Okay, there is some normal reaction acting on the man upwards. Okay, and his weight is acting downwards, right? Normal reaction is upwards. So we know what does the weighing scale show? It shows the reading equal to what? Which is normal reaction. Reading equal to the normal reaction. That's the weight. We have studied this. What is weight of person? It's equal to the normal reaction exerted by the floor. If normal reaction is 0, the weight will be 0. Weightlessness. Okay. So now we have to find out the normal reaction. So the lift is moving upwards with 5 meters per second squared. So there are two forces. One is M, N, and another is mg. So we can say the acceleration is upwards. So the forces acting on that man, let's consider the man only. Okay, it is m times a, his mass multiplied by his acceleration, and it is equal to net upward force, which is the normal reaction, minus net downwards force, which is mg. Okay, so take mg on the other side. So you get normal reaction equals to what? M multiplied by g plus a. Very simple. Okay, so it is M is 80, G is 10, A is 5. So this is 15, 15 times 80. How much? 15 8s are 120, 1200 newtons. Okay, this is the answer. Option D. Understood? All right. Next question. A lift of mass 1000 kg. See how many times it is repeated. Okay, these are all NEET questions. Okay, these are all NEET questions. A lift of mass 1000 kg which is moving with acceleration 1 meter per second square in upward direction. Then the tension developed in the string which is connected to the lift is. So it is 1000 kg and it is accelerating upwards 11,000. But see, there is this option also 10,800. Okay, so tension is m multiplied by g plus a. These options are closed, no? So we have to take real value of g. This is 1000 multiplied by 9.8 plus 1. So this will be 10.8 multiplied by 1000. Okay, 10,800. This is the answer. Next question. Now, a monkey is descending from branch of a tree with constant acceleration. Okay, monkey is descending from branch of tree with constant acceleration. If the braking strength of branch is 75% of the weight of the monkey, that is the tension that can be withheld with what? Branch of the tree. Okay, if it gets more than that, then the branch will break. The minimum acceleration with which monkey can slide down without breaking the branches. This is also a similar question. Okay, this is the, let's suppose, branch of tree and it is vertical, and the monkey. Okay, what's the difference between man and the monkey? Monkey has got tail. Okay, so he is descending downwards with acceleration a. So there will be tension in this branch upwards, okay, and his weight downwards, m times g. Okay, so net force is downwards, a is downwards, so that means m times a is equal to what? Mg minus the tension, right? So now we could use direct formula, T is equal to what? Mg minus ma, or m multiplied by g minus a, because he is descending downwards. But because I wanted to explain this, so I explained it. Okay, so this is equal to m times a is equal to what? Mg, the net downward force, minus tension in the string. Okay, tension in the branch, not string. Okay, so how much is the maximum tension that that branch can take? It is the 75% of his weight. So we can write this is 75 by 100 of his weight times mg. Okay, so this is 3 by 4, right? 75 by 100 is 3 by 4. So 1 minus 1 by 3 by 4 is 1 by 4, right? So this will be equal to mg by 4 is m times a. M gets cancelled. What's the answer? A is equal to g by 4. Next question. Another monkey. A monkey of mass 20 kg is holding a vertical rope. So similar question. The rope will not break when the mass of 25 kg is suspended from it, but will break if the mass exceeds 25 kg. So that means the maximum tension that the rope can take without breaking is 25 times g. Okay, so let's suppose g is 10, so it is 250 newtons, right? So if it exceeds 25 kg, it will break, right? That means maximum tension that it can take is 25 g. Then what is the maximum acceleration with which monkey can climb up along the rope? So we know when monkey climbs up with some acceleration, then in that case tension will be equal to what? M times G plus A or mg plus ma. Okay, and this is equal to what? 250. So what is mass of monkey? It is 20 kg. So it is 20 times g. G is how much? 10. So it's 250 plus 20 times a. So take this 20 times 10, 200 on other side. So this will be 250 minus 200, 50. 50 equals to 20 times a. 20 times a is 50. So a is 50 divided by 20 or 5 by 2, that is 2.5 meters per second square. Okay, so this is the answer, right? Another question. Mass of 1 kg is suspended by a thread. It is lifted up with acceleration 4.9 meters per second squared, lowered with acceleration 4.9 meters per second squared. The ratio of tensions is, so lifted up, let's suppose tension is T1, so it is M times G plus A. Okay, lowered down, let's suppose tension is T2, it is M times G minus A. M gets cancelled, G plus A divided by G minus A is the ratio, and this is 4.9. Okay, so it is 9.8 minus 4.9 divided by 9.8 plus 4.9. 4.9 is half of 9.8, right? So this is 4.9 divided by, this is 3 times 4.9 because 9.8 is 2 times 4.9. Okay, so this is what? 4.9 divided by 3 times 4.9. So 1 by 3 is the answer, right? Oh, I did the opposite thing, right? Sign is wrong. Sorry, sorry, sorry. So 3 by 1 is the answer, not 4 by 3. Not 1 by 3. Okay, sorry. So 3 is to 1 is the answer. Okay, option C. Okay, I will read the question again. 3 blocks of masses, okay, M2M, 3M are connected by strings as shown in the figure. After an upward force, capital F, is applied on block M, the masses move upward with constant speed v. Masses are moving upward with constant speed v. Okay, what is the net force on block of mass 2m? G is the acceleration due to gravity. It would be 0, yes or no? They are moving upwards with no acceleration, moving upwards with constant speed v. Yes, no? Okay, there is no need to solve at all. Even if we solve, we will get 0. Okay, but they are moving upwards with constant speed v. There is no acceleration. That means net force on all masses is equal to 0. Okay, so net force is equal to 0. So can you tell me what would be the net upward force acting on these three masses? It's simple. It is equal to net downward force. And what is net downward force? Why is it equal to net downward force? Because there is no acceleration. So net upward force, which is F, is equal to the net downward force. And net downward force is their weight. Okay, so m plus 2m plus 3m, that is 6m, 6m times g. Okay, so value of F is equal to what? 6 times mg. So let's suppose that we have a rigid support like this, and there is a spring connected to the rigid support, and we have a mass connected to the spring. Okay, and the mass is resting on a table. Okay, so what do we have? We have this rigid support, a spring connected to the rigid support, and the other end of the spring is connected to a mass. Okay, mass M, let's call it mass M. Now, if I stretch this mass, what will happen? If I pull the mass, what will happen? The spring will get stretched. Okay, so as the spring gets stretched, there is a restoring force generated in the spring. Okay, as the spring gets stretched, there is restoring force generated in the spring which acts in the opposite direction of the stretching. Okay, and if you compress the spring, then also there is a restoring force generated in the spring which is opposite direction as that of displacement. Now, if you compress it, it will try to expand. Okay, so that restoring force wants to restore the spring. Okay, it wants to restore the length of the spring. It doesn't want any change in the length. So the Hooke's law says, the law is given by Robert Hooke, and it says that the restoring force generated in the spring is directly proportional to the displacement. Okay, the restoring force in the spring, which is also called as spring force Fs, is directly proportional to the displacement, and it acts in the opposite direction of the displacement. Okay, so if you compress it, it wants to expand, and if you stretch it, it wants to come back to its initial shape and size. Okay, so the restoring force acts in opposite direction as that of displacement. Okay, so if you stretch it, let's suppose you stretch it like this, so displacement is towards right, the restoring force will be towards left, right? And if you remove this proportionality sign and put an equality sign, there will be a constant K. Okay, so spring force is equal to minus of K times X, and this constant K is known as the spring constant. The spring constant, and it is different for different springs. Is the Hooke's law clear? Yes, no? All right. So now let's suppose we have this rigid support and there is a spring. This spring connected to the rigid support, and we connect a mass M to other end of the spring. So what we will consider is the spring is the ideal spring. So ideal springs are massless, okay, and inextensible. So that means doesn't matter how many times you stretch them, there won't be any permanent extension in the length. Okay, so they are massless and inextensible, ideal spring. Okay, so let's suppose the spring is ideal, and now I want to find out how much would be the extension in the string. So what should we do? What are the forces acting? So there is downwards force acting on this weight. It's equal to what? Mg. Okay, and there will be a restoring force acting vertically upwards. Okay, so let's suppose displacement is x. So let's suppose the original length was up to this much, and this much is the extension. X is the extension in this string. Okay, so we know this force will be equal to what? It is in opposite direction, so F is equal to minus of kx, but in magnitude it is equal to kx. Okay, so till what time this extension will continue? Till the time mg becomes equal to what? Kx, right? Till the time mg becomes equal to kx, and therefore what can I say? That the system will come in equilibrium. Okay, it won't move, it won't accelerate downwards, it won't accelerate upwards when mg or f is equal to mg. Okay, that is kx is equal to what? Mg, and therefore x is equal to mg divided by k. Okay, so this is the principle of weighing scales. Have you seen weighing scale? Spring balance. This is the principle of spring balance. Okay, so there is a numbered scale like this, and inside that one there is a spring and there is a hook connected to that, and you hook some mass over there, so it shows some extension and it gives you what? The reading. Okay, it gives you the weight. So that extension, it is directly proportional to the weight. All right, so this thing is clear. Okay, so let's move on to the next problem. So two blocks A and B of mass 3m and m respectively are connected by a massless and inextensible string. Okay, so it is a spring actually. The whole system is suspended. Okay, they are connected by this string. Okay, right. The whole system is suspended by a massless spring. This is a massless spring as shown in the figure. The magnitudes of acceleration of A and B immediately after the string is cut. So when the string is cut, what will be the acceleration of A and B? That is what we have to find out. Okay, this is from NEET 2017. So for that, we have to draw free body diagram. Okay, so now let's draw free body diagram of A. So there is tension in the string acting downwards. Okay, this is A, this is 3m, right? So first of all, let's find out this tension in the string. So this mass B is there. Okay, so on this mass B, tension acts upwards, its weight acts downwards. So how much would be the tension? T is equal to mg, because it is in equilibrium, it's not accelerating upwards or downwards. Okay, so T is equal to mg. And now let's draw a free body diagram of A. So there is tension acting downwards, T, which is equal to mg, and weight of this mass is acting downwards. So weight is equal to how much? This 3 mg, right? Its mass is 3m, weight is 3 mg, and there is spring force acting upwards. So spring force is acting upwards. Okay. So now, how much is the spring force if the system is in equilibrium? Okay, this is spring force. F is equal to what? 3 mg plus mg. Okay, so it's equal to 4 mg. And now, what you are doing is, you are cutting this string. Okay, so when you cut the string, what will happen to this mass? What will happen to this mass? So this is mass B. So when you cut the string, there is no tension, T becomes equal to 0. So there is only one force, which is mg, and therefore it will accelerate freely under gravity. So acceleration is equal to what? G for B. Okay, and what happens to A when the string is cut? Okay, when the string is cut, now spring is stretched, right? Spring is stretched. The moment you cut the string, the spring is stretched. So net force upwards is F only. It won't change instantaneously. But the downward force, now because the string is cut, this mass M is cut from there. Okay, so you have only this mass. So its weight will only act downward, which is 3 mg. So how much is the net force? So net force is upwards. Okay, so net force is this mass 3m multiplied by acceleration, and it is F minus its weight. which is 3 mg, right? And therefore acceleration will be equal to F, which is 4 mg. I will write 4 mg minus 3 mg divided by 3 mg. So mg will get cancelled. 4 minus 3 is 1. Okay. So 1 by 3. Sorry, I wrote extra g here. Okay. Mm gets cancelled. So it is 1 by 3g or g by 3. G by 3 is the acceleration upward. Right. So what is the answer for A and B? Accelerations are g by 3 and g respectively. So option A is the answer. All right. Let's move on to the next question. A balloon with mass m is descending down with an acceleration a. A is less than g. How much mass should be removed from it so that it starts moving up with acceleration a? So balloon is accelerating down with acceleration a. How much mass should you remove from it such that it starts moving up with acceleration a? This is the question. So let's draw a balloon. So let's suppose this is a balloon. Okay, it is accelerating downwards. It is accelerating downwards. So its weight will act downwards and there will be a force. What force? There will be an opposing force due to the air. Okay, so that force is suppose F, because it moves through the air. Air exerts an upward force, upthrust it is called. Okay, so the upthrust is equal to F. So now how much is the net force? So since it is accelerating downwards, net force I can say it is downwards. Okay, and it is mass multiplied by acceleration. So it is m times a equals to, I can say, mg minus f. So let's call this equation 1. Now what you are doing is you are removing some mass from the balloon. Okay, so let's suppose there were 2-3 people sitting inside the balloon. You throw one of them outside. Okay, or whatever, there is some mass inside the balloon, you remove some mass such that it starts accelerating upwards. So this upthrust will be more than the remaining weight. So let's suppose the remaining weight is m dash. Okay, remaining mass is m dash. So what can I say? Now the mass is m dash. Okay, so force is F and weight is m dash times g. Okay, and it accelerates upwards now. So I can say m dash times a, because it is accelerating upwards, is the net upward force, which is F, minus m dash times g. This is your equation 2. Okay, you can add those two. Now why I have written same F for the upthrust? Because upthrust depends upon this area of the balloon. Okay, it depends on the area of balloon. Okay, and it doesn't depend on the mass. All right. I'm sorry. This thing we'll learn afterwards. Okay, it is called as the Stokes law. Okay, but for this problem, this much is enough, that there is a constant force F, the upthrust due to the air, which is acting on the balloon. All right, so now we can add these two equations. So what do we get if we add these two? I get m times a plus m prime multiplied by a is equal to, on right hand side, this f and minus f and plus f gets cancelled. It is m minus m dash multiplied by g, or I can say mg minus m dash into g. Okay, so from here I get formula for m dash, right? So m dash into g I can take on left hand side. So m dash times a plus m dash times g is equal to, I will take this ma on right hand side. So it is g minus a multiplied by m, and I can take m dash common, so it will be g plus a here. Okay, and then I can add, I can take m dash common, so m dash is taken common to g plus a, and this is equal to what? G minus a multiplied by m. So m dash is equal to g minus a divided by g plus a multiplied by m. So this is the, okay, question is how much mass should be removed from it so that it starts moving up. So this is the leftover mass of the balloon. Okay, so how much mass is removed? The mass removed is equal to m minus m dash. Change in mass is m minus m dash. Okay, so that is m minus this thing, g minus a divided by g plus a multiplied by m, or you can make the denominators equal. So this will be g plus a multiplied by m. I am multiplying and dividing by g plus a with m, minus g minus a multiplied by m divided by g plus a. So you get g and g will get cancelled out. A times m, and this minus minus becomes plus a times m. So it is 2a upon g plus a multiplied by m. This is the answer. This is the change in mass. 2a divided by g plus a. Okay. Option A is the answer. So you got this.